Okay, 1 second. Hi, everyone. We're happy to have today Walther Zeug with us. And Walter is an interdisciplinary researcher, postdoc, and working group leader at the Helmholtz Center for Environmental Research, Research Unit Environment and Society. His long-term research interests are political economy and ecology, inter and transdisciplinary sustainability research like LCA, sustainability analysis and assessments, and democratic economic planning. And also, I don't know if Jakob Heyer is right now in the call, but Jakob and Walter have like a deep research relationship, and they worked on the model that Walter is going to present us today together. And I was supposed to introduce Jakob super quickly. So Jakob is a PhD candidate at the University of Jena and is investigating more recent model of a democratically planned economy. And a short description of our event. So, amid the escalating social-ecological crisis, which exposes the systemic shortcomings of our current economic models, we must reconsider systemic alternatives, such as democratic economic planning. In our model, planning, talking from Walter and research's point of view, in our model, planning, understood as the long-term organizational anticipation of actions, operates on multiple levels: strategic central coordination, scientific societal accounting, and autonomous local coordination and production. We advocate for integrating advanced sustainability science, cybernetics, and life cycle sustainability assessment methods into a holistic modeling and accounting framework that unites economic, ecological, and social dimensions. This integrated approach presents a concrete, solution-oriented model and tool for discussing an economic system capable of meeting societal needs within planetary boundaries, an innovative vision for the INDEP network's dialogue on democratic economic futures. And I'm going to post a couple of other links, for example, Walter's Blue Sky in the chat, but for now it's Walter, your turn. Take it away.
Yeah, thanks for joining us today. So I'm sharing my screen and I hope everybody can see it, right? Fine, all right.
Yes.
Yeah, so what we're going to do today is I'll have a presentation, maybe around 30, 40 minutes, and then we have an open discussion. And yeah, thanks for Eric and the INDEP team for organizing this and the nice introduction. And yeah, so basically, this concept of a CDEP, so a cybernetic democratic economic planning, evolved from a long-term research on sustainability and sustainability assessments. And as Eric said, I developed this with Jacob Heyer together, at least this application to a future more or less utopian cybernetic democratic economic planning. I'll start by a short introduction to interdisciplinary methods of sustainability and environmental system research science, an introduction to what DEP, cybernetics, and holistic accounting actually is. Then I'll talk on some general implications and scales, as well as, and this is then the core, the framework of this CDEP model and the holistic accounting, which is others to us, and as well as drawing some short conclusions. So yeah, let's dive into that. Maybe let's see what the general challenge is maybe. And I would say the challenge is that former socialists, but also current capitalists, social relations to nature, they accumulated in a socio-ecological crisis. And you can say this socio-ecological crisis is that we transgress planetary and regional ecological boundaries. And at the same time, we are not able to fulfill social needs equally and sufficiently. No. And the, let's say, research question, which results from this is, how can we achieve a good life for all within planetary boundaries? And I mean, who is against that? Yeah? So And that's the challenge, I would say. And this means precisely to identify pathways or methods to determine how much and which resources we actually can use through economic, technological, social practices to sustainably fulfill societal needs. Yeah. And the challenge evolves more or less from these questions. And these are the questions I am trying to address in the next minutes. Let's have a look at where we come from. So I would perceive in a very technical way the problem like that. So since the 1950s, we have something which is also sometimes called a great acceleration. That means we have an exponential growth of the production of commodities or goods. And we have an exponential growth of ecological impacts and resource use. So way above the planetary boundaries, which I just assumed as static there, as linear, which is not actually the case, but just simplification. However, there was only a more or less linear, but way lesser increase of the degree of fulfillment of social needs. And what you see here is more or less, let's say, the empiric dimension of exchange value versus use value, right? So what is more or less the challenge of a social-ecological transformation in the future? Of course, it should look something like that. No? It should be an exponential, more fulfillment, or let's see, just the sufficient fulfillment of social needs. However, we know that we have to decrease the production of goods in order to get with the ecological impacts and resource use below planetary boundaries. So there is actually a need for a double decoupling, as I called it. And this double decoupling consists out of two dimensions. The first decoupling dimension is that we have to decouple the fulfillment of social needs from an ever-increasing production of material goods, so sufficiency and efficiency. And the second decoupling dimension is that we decouple the still needed sufficient material production from increasing ecological, social, and economic impacts. So it has to be efficient as well. So sufficiency, effectiveness, and efficiency. I also determined three definitions of what sustainability actually could be. I would say social sustainability means that we have a long-term and global fulfillment of social needs as well-being as the end. So that's the whole point of our endeavor. That we have technologies and economic structures which are so efficient, effective, and just that they actually enable us to fulfill social needs within planetary boundaries. That's economic sustainability. And ecological sustainability is staying within planetary boundaries, right? What is economy? If you really have scaled it down to the very processes of what's happening there when you're producing materials or products. So economic processes look something like that. So you have inputs and outputs, and there's a complex system of manufacturing, use, maintenance, recycling, and so on and so forth. If you look closely, these production systems or these elements, we call them processes of production systems, they include physical and social interactions of this societal metabolism. So they are processes, and these processes have inputs and outputs like energy, materials, products, emissions. These inputs and outputs, but also their effects, they can be modeled and measured by this HILSA method, which stands for Holistic and Integrated Life Cycle Sustainability Assessment. And that's a method which I developed in the last years as a tool for sustainability assessment. So what we can measure here are the socio-economic inputs, the material and energy flows or throughputs, and the socio-ecological and economic effects. And this method is data and software implemented. And current databases on the current economic system entail over 20,000 processes. And we can measure the social, ecological, and economic effects with currently around 100 qualitative and quantitative indicators. But of course, this tool is more than just measuring. It's also a tool for actually a very detailed natural and social accounting and economic networking. And this is basically what we came up with here, and I show you in a sec. If you consider planetary and this is even more important, regional boundaries, of course, you have to say, well, what are they? So, and it's not so easy to quantify them, but actually it is, we are able to quantify them, not only on a planetary scale, but we can downscale them and allocate them. And this downscaling and allocation is oftentimes done to per capita. And I don't want to go into detail here. But if you look closely, you can differentiate between global and regional boundaries, and then biotic, abiotic, or climate boundaries. And there are more or less, let's say, two main planetary boundaries. The one is the raw material consumption. So this involves all the materials which have to be moved, processed, and so on and so forth in order to produce something. And the other one is the greenhouse gas emissions into our atmosphere. And you can tell from Earth system science that about 5 tons of raw material consumption and about 1 ton of CO2 emissions per year per capita is sort of sustainable. So you can downscale planetary boundaries to per capita, but actually the question is then how to upscale this again to the production of specific products or to the consumption of these, let's say, materials, or the consumption of the atmosphere, you can also say, to some sectors. So this is the big question. And this question actually scientific methods and models try to solve by something which is called absolute sustainability assessment. However, this absolute sustainability assessment is a very technical way of allocation. And what I say, and Jacob, we say, actually doing this allocation is a highly political process. And this highly political process should be organized democratically. And maybe it's even more than just an allocation. Maybe it is a whole new approach for an economic system, which allows us to achieve this good life for all within planetary boundaries. So speaking of which, what is actually meant by democratic economic planning? We use this term cybernetics, and cybernetics is the science of control of complex systems. So that means that we are able to set specific properties in line with democratically defined goals. And this is done by parameters and rules of interactions between autonomous subsystems. And mostly it's done by feedback loops. Basically, cybernetics is a lot about feedback loops. And the cybernetic democratic economic planning means that we have a primarily democratic, that means parametric control of the framework, but without discussing, let's say, every detail on a global scale. So this is then the parametric control. And in these parametric control frameworks, local units plan and act relatively autonomously. So this allows to let's have local specific actions with local specific knowledge, in convergence with macro plans. For example, the macro plans on how to save the climate. And this is a big difference of this model in difference to, let's say, historic models of socialism or so, where actually this was never the case, that you had this parametric control, that it was democratic, and that there was this local autonomous acting organizations, and also on the effectiveness which comes through that. So These coordination is then an iterative process on multiple levels, and it's more or less the challenge is always to have the convergence of the micro and the macro plans. And I talk about that in a second. And to achieve this, the local subsystems, they have to be enabled to do that by a good information system, which actually allows them to assess the consequences of their doing in the overall systemic dimension. So already 100 years ago, Neurath was discussing this problem by the incommensurability problem. So that means that there is no common denominator of such a measurement or such an information. So you can't just have one information because this is always pseudo-rational. And what you actually need is a calculation in kind. So that means some sort of calculation which can, let's say, grasp the incommensurable goals and which allows for multi-criteria decision making. So what we actually need is a disaggregation and an aggregation. That means an aggregation of a very complex system of informations on planning, budgeting, and accounting. But on the other hand, also a disaggregation so that we are able to have a look at these details, especially when there are trade-offs and incommensurabilities at any point. The goal, which we can derive from that, is that we need a differentiated and multidimensional complexity reducing, but not complexity discharging system of parameters. And this is what we think is best possible by a holistic and transparent system of parameters, which we call tokens. And these tokens are, let's say, very highly aggregated units of account, which represent certain details or all the other 100 indicators. They are not replacing the 100 or 1000 qualitative and quantitative indicators and specific measurements, but they are representing them to a certain way. On which scales do we talk about the CDEP? So we differentiate between three scales. The tops, or the, let's say the top level is the level of essential planning and control, which is also the level where the a highly democratic and participatory process takes place, and where we actually, as a society, decide, okay, what are these parameters, and what do we say are actually planetary boundaries, and we set the goals as a society for that. Then there's a level for holistic overall accounting, and there's a level of decentral parametric allocation, planning, and production, as well as reproduction. So before we start talking about this in detail, very important is to see that the following concept is an intermediate approach for socio-ecological transformation. It's not the vanishing point of some sort of communist utopia or so. This may look totally different. What we see in 5 seconds is something which you can imagine as something, if everything goes well, maybe we come around with something like this in 20 or 30 years. But it won't be something which stays for another 1,000 years or so. So, as I said, this concept aims for this good life for all within planetary boundaries, but as well as to take care of us as we would like to. So care and care work plays a significant role as well into that. The democratic macro plans on the top level, they define the general priorities, the development direction, the investments, and also how much of the resources we want to allocate to unconditional universal basic income and unconditional universal basic services, as well as what are actually planetary boundaries. So planetary boundaries are not something nature gives to us or so. Actually, nature doesn't care at all how much CO2 we put into the atmosphere. We have to define how much we consider as sustainable So it's not blowing up the Earth, basically. So it's planetary boundaries are societal boundaries we set. Um, so that means these planetary, but as well as social boundaries, are a result of an ongoing process, of an ongoing democratic process of social deliberation, but also supported by scientific analysis. And the tokens we are talking about in a second, they are not money. Tokens are non-circulating units of account, and they reflect information about these holistic costs, scarcities, but also utility of products in a certain way. And these tokens are stored and transferred on virtual accounts, and these virtual accounts are under a societal control. So organizations cannot privatize their budgets. They can also not accumulate budgets without a societal control. And that's the big difference between a privatized budget in terms of money or so of a company. Okay, with this having said, let's have a look at this framework. And this is more or less the core of the discussion, I would say, today. Everything you see in black means material and energy flows, and everything what you see in blue is budget informations and flows, which also act as a signal of relevance. As I said, we have these three leading indicators, and these three leading indicators we also assume as budgets. And there's raw material consumption, as I said, greenhouse gas emissions, and working time. So working time also, let's say, represents to some extent these social efforts we have to make. And we can define per capita budgets per year, and these are these 5 tons raw material consumption, 1 ton of CO2 equivalents for climate. And for working time, I just took the current working time of paid and unpaid work in Germany per capita per year. Of course, all of that can change. Yeah, maybe we say, I don't know, we just want to work half of that time. Then it's fine because that's just a parameter we set as a society. So don't look too close at the numbers itself. And these budgets have to be, let's say, allocated to 5 economic sectors. And the first sector is the universal basic income. So that means basically an income which is unconditional for all of us, and it's the same, and this allows us for individual consumption. Then social reserves, as well as universal basic services. So this means schools, infrastructure, childcare, daycare, hospitals. Yeah, so everything of that is there, independent of your universal basic income, as well as there are budgets, additional budgets for non-institutionalizable care work. That means if you have to take care of a child or of an elderly person, and there's productive consumption, which is basically investment. So here you have the budgets in this table. And these budgets now allow for the consumption of goods. And this is, let's say, the consumption system, which also includes reproduction already. And this consumption has to be fulfilled by a production system. And as you see, production and consumption is sometimes hard to differentiate when it comes to reproduction. But what we also want to implicate here is that it's about also, let's say, have not a strict separation of spheres between work or care work and production and reproduction. So it goes hand in hand. The actual impacts, and that's why they are written in small letters. So the actual impacts of this production system we can measure with the Hilsa method. So with this LCA method. So we know precisely how much working time, greenhouse gas emissions, and raw material consumption we have in each production process. But we also know more than that with the 100, or you can also come up with 1,000 indicators. But here it's about the 3 leading indicators. If you know that, you can derive product-specific impacts. So that means the raw material consumption, the greenhouse gas emissions, and the working time which was needed for one product P. And of course, if you take all the products And the amounts of all the products, you have the economy-wide impacts. So these are the measured impacts. This is what we measure. And now comes the first cybernetic loop. And this is the comparison of the measured impacts with the budgets. And if the measured impacts are smaller than the budgets, then we consider this as sustainable. If not, we have to adapt these budgets and we have to adapt the system itself. Also, we can derive single product prices. So let's say a price of a product in this case is just the ratio of the raw material consumption of this product compared to your per capita budget in general, not individual consumption, in general, per capita budget. And so the price here is, let's say, a raw material, climate, and social price. And these three prices represent the share of this one product on your societal budget per year per capita. And of course, by having these prices, we can incentivize the consumption again, so that it is clear that maybe you can consume 10 kilograms of potatoes each week, but maybe not 10 kilograms of meat. Or that you can, of course, have one bike every 10 years or so, but maybe not a fridge every month. So this gets clear by these prices, which indicate the social, climate, and raw material costs in a way. This is the top level of planning and control. And then there is a level of overall holistic accounting. And it gets a little bit technical here. But what we actually do on this accounting level is we have to know which regional, global, and global budgets are sustainably available. So that means which fossil, biogenic, but also socio-economic resources we have. And we can allocate these resources to specific production sectors. And these production sectors, again, which include reproduction, they are also interlinked with each other. So every of these production sectors as one is as well linked with a production sector as two. This is input-output analysis, what you basically see here for everybody who may know. But if you're not familiar with that, you can also just have a Google on that. So input-output analysis makes basically such an allocation possible in very complex economic systems. And of course, all of these products from the production sectors go into the consumption outputs. And the consumption outputs here are, again, universal basic services, resources, reserves, universal basic income, the non-institutionalized care, and the productive consumption. And so we can precisely track with which technologies and with which value chains by LCA we use which resources for which consumption. And you can extend this table. That's then, let's say, an environmentally extended input-output table by the three leading indicators on RMC, greenhouse gas emissions, and working time. So all of this information on inputs and outputs, stocks, performances, and so on and so forth is actually recorded by using LCA datasets in the organizations. So this is nothing somebody from outside measures, but actually that's what the companies and organizations on the very top-down level measure themselves. Because what you actually need to know for doing an LCA is basically only what are your inputs and outputs. And this is what basically every producer or every organization knows. What are the inputs and outputs? And that's the only data which is required from the very basic network. The good thing is you, by let's say, uploading this data as a producer on your inputs and outputs, you can also establish regional and supra-regional transparent platforms for material exchange or for intermediate products. Assume you are, for example, a bakery, right? And there is some sort of byproduct you have as a bakery, for example, heat. Yeah. And let's say you just put it as an output into the database that there is some heat as a byproduct in a very specific location, and maybe somebody else, um, let's say a sauna or something like that, is looking for heat in a specific region. Maybe they are your neighbors and they need this heat. Yeah? So there's the opportunity for having also material exchange platforms on a very basic bottom-up level. Yeah? Okay. And how is it looking, let's say, in all-day life or more or less on the micro level? And this is the level of decentral parametric allocation and reproduction. Let's assume you are some entity which has consumption. So this can be an individual, but this can be also a kindergarten or so, and they have a need for bread. This bread has to come from a bakery. The bakery itself, again, they have to have wheat from a farm as inputs, and they also need machines from a factory. We know precisely what are the product efforts for that bread by measuring what are the raw material consumptions of the bakery, the factory, and the farm. And we know what the price is of that. And if you want to consume the bread, you transfer in these democratically controlled, transparent accounts of tokens, you transfer your budget first, precisely this budget to the bakery, which the bakery had as costs or as efforts. And the budgets for the farm are as well transferred to the farm, as well as for the factory, the budget in terms of, let's say, costs or efforts for the machines. And they, again, let's say from this point, and this is really not controlled by the farms themselves, but really in the social control, then the budgets are automatically, let's say, pushed through the system to the very much more, let's say, in the upstream, in the upstream of these value chains. What you see here is the simple reproduction. OPEX, and I just in a second I will tell you what the other sphere is. So what you see here more or less is that these, on a micro level, these token budgets are transferred as accounting units, and you can also imagine it like a GTG, like a good token good system. So it's if you consider like capitalism as capital and commodities. Here it's more or less of a GTG system, and that's why it's also not like a capital accumulation. What happens if companies produce more effective and more efficient? And if they produce more efficient, then the price in terms of the costs needed for budget decrease. Then more of these goods of this company are consumed and more tokens get passed there. So let's consider, or let's imagine we have two bakeries, and one bakery A is producing the same bread as bakery B, but it's producing it with less efforts, less impacts, because they have some special, let's say, technology or practice or so. Of course, people or institutions will get a bread from bakery A where they need to invest or they need to transfer less budget to them. And this, let's say, from this benefits, and by this we also see as a signal of social relevance that the goods of this bakery A are needed, and they are needed more, or there's a higher preference for these products than for bakery B because they are better in quality and or there are less efforts for that. But not as in capitalism, we have here a solidarity competition. That means bakery B does not necessarily has to close down, but maybe bakery A and bakery B come together and let's share the knowledge on why bakery A is actually better than bakery B. Yeah? And if there's no overproduction, it's perfectly fine that bakery B just stays. The good thing here also is that we have an automatic adaptation of production to changing framework conditions. So let's assume over time, maybe we get very close at dealing with climate change in a good way. So maybe we really get close to a net zero scenario. But the raw materials or the working time gets more scarce. Because we include this in the budgets and the budgets themselves are changing, it is perfectly possible that the bakery A, which changes its production technologies in a way that they are not so resource intensive, will get again more budgets, more consumption, and a higher signal of relevance. Yeah, so that's why you have, by this parametric control, a bottom-up adaptation of the production systems to the changing framework conditions. There's also another sphere of expanded reproduction and innovation, and this is more or less the productive consumption budget, or let's call it the investments. So we differentiate between the operational expenditures, that's the gray area. So that means the production and the pre-products, they are acquired by receiving tokens and passing them through from the consumption. That's also called simple reproduction. And there are investment expenditures. For example, if you have to expand your means of production or you want to do innovation, then these tokens for productive consumption, which allow you to experiment, which allow you to innovate, which allow you to get bigger or better machines. These budgets for investments are handed in a flat rate budget so that there is no bureaucracy on having a proposal or a call for every tiny innovation. But also there are bigger budgets which are under institutional control. So you can also think of that like, let's say, democratically controlled banks, which allocate bigger budgets for investments and innovation, but not for the sake of profit, but for the sake of social welfare. Okay, I mean, in a very simple way, if you go to if you go to any store or facility in such a central cybernetic democratic economic planning society or so, maybe it's not a price like one price you have on a product, but life can be simple, and you just see, okay, what is the raw material, greenhouse gas emission, and societal price of the product I'm consuming, and how much of the share of my budget is this taking? Yeah? And it's maybe something we are already familiar with. If you are looking at such nutritional information on products, at least here in Germany, but it's also, I know that's somewhere else. And I mean, dealing with such budgets or so, by the way, is also not very uncommon in gaming. To have like maybe more than one, but 3 or 4 units of account. Okay, coming to an end with the conclusions. So this cybernetic ecological democratic planning aims to solve basically the questions of which resources we can use and what we want to produce in a societal deliberation, but in an algorithmic and technical way with advanced methods, so that we have to solve not this very, very complex systems by over and over ongoing discussions. But there is, let's say, some form of efficiency and cybernetic regulation with feedback loops within the system. Of course, our approach is not, let's say, the system which controls the society. It's a result of a model development. And what we want to do in the future is we want to actually do simulations and calculations of the system. We want to really quantify these parameters and indicators as well as the token system and maybe substantiate with agent-based modeling. All this will be a subject of the upcoming articles. And of course, we cannot solve this problem on our own, but we see it just as one module, and we want to invite you to collaborate. So that means what is missing in our model or in the model I just showed you? Actually, it's a lot because what is missing is the political system. So what is actually the political and the societal relations there? That's maybe implicitly here, but it's not explicitly. So it's not a political system or a social system. Maybe what I just showed you is just a very tiny piece of a future society, and not like the controlling mechanism or so, like a totalitarian mechanism of controlling society. Transformation strategies would be something we are really interested in, and of course, a lot of these details. So yeah, feel invited for a discussion and to maybe contribute to this discussion of democratic economic planning in general, because what I showed you here is only one maybe very tiny module of this societal and democratic discussion on yeah, how to yeah, maybe get something out of this society in the next 100 years without just crashing. Yeah. Okay, by that, thanks for your attention. Here's some of the literature. You can check this in detail. Most of this is also open access, and you can also check out Jacob and mine profile. Yeah, thanks for the attention, and I'm looking forward to the discussion.
Okay, thanks a lot, Walter. I would stop the recording now.